Hey everyone, welcome. Welcome to the virtual edition of DH520 Python. This is going to be the first of a series of video lectures that I'll record and put up. These are just the slideshows that I would normally have done in class anyway. Those slideshows, as you know, are already posted on eClass, but I'll just talk through what I would normally talk about in class. And remember, these are not really intended to be a full replacement for the class activities. This is just a supplement. So we're still having some synchronous meeting during the week, maybe an hour and a half during class time. And we've got the DH Lab sessions that are going to be running on Tuesday mornings. We've got a Slack workspace with a whole bunch of channels there so you can ask questions. We've got the eClass Q&A up, and you can always email as well. So take advantage of all of those different opportunities. I know that it's harder when we're not meeting in person. There's a lot of interplay and a lot of Q&A that can happen. There's a really fast feedback loop that happens in class, which is really good for learning. And when we're remote, we just don't have the speed of that. So we have all of these different opportunities, so take advantage of those. So let's get started with the lectures. And obviously, if you have questions, post those on eClass or Slack, or come to Virtual Office Hour. Thanks. All right. Well, in this lecture, we're going to talk a little bit about variables in a computer program, which are really nothing more than data containers. As we'll see as we go through the entire rest of the semester, data is a little bit like water. That is to say, unless we put it into some sort of a container, it just runs through our fingers and we don't really have access to it. So in that sense, there isn't really any reusable data that's free floating inside a computer program. And so one of the things that we're going to do as we go through this semester is understand the data that we're trying to represent, and we'll try to figure out a good data container to put that into. There are some choices that are better than others, and we're going to see that as we go through the term. Running a computer program is really nothing more than figuring out how to do a task, say using pencil and paper, and then translating that process into a language that the computer understands. And for us, that's going to be Python. But if we can't figure out on pencil and paper how to go about doing a task, then we really can't explain that to the computer. There's no magic in there. The computer doesn't really understand all kinds of operations or sequences or things that we can't really do ourselves. So, in that sense, my argument is that writing a computer program is really a form of writing. And in fact, it's much more like writing poetry than it is about doing anything else like math. So, for example, if we wanted to count all of the words that occur in a poem or find out what they are, we could write down in English a series of sequences or a series of steps that we could do, like here, create an empty list of words. That's a data type we're going to talk about in a little bit. We'll look at every line in the poem. We get rid of the punctuation. You break the words in the spaces, add the space characters, etc., etc., etc. And then we kind of repeat that. All of these instructions have to be as precise in Python as we can make them. And my joke is actually that we have to be precise enough that we could even get somebody like Homer Simpson to do them, right? So we're writing them down with absolute total precision so that somebody who is not really capable of creative thinking like Homer Simpson could actually go through and do all of those things step by step and then get the right answer, get the answer that we're expecting, or get the list of words that we're expecting at the end of the poem. In our case, a little Python program is going to look like this. So if this doesn't make sense yet, it will soon in a couple of weeks. That result is a computer program, or sometimes we call it synonymously a script. All it is a plain text document, right? We don't even use things like Microsoft Word or anything like that. In fact, we don't want to, because Microsoft Word has tons of formatting stuff in there that Python just doesn't get, doesn't understand. So that's why I've asked you to download a good programming text editor, because that's the tool we're going to be using all the way through the semester. So in that sense, a program starts at the top. Every line of the program is like a line in a poem. Python starts executing it at the top, and it performs each one of those statements or executes each one of those statements one by one as it goes down through the bottom, down to the bottom where it just falls off the end. So again, these programs are much more like poetry than they are like math. And every programming language has its own kinds of expressions. It has its preferred ways of expressing concepts. Python has its own ways to do things. Sometimes programmers use the adjective Pythonic as a way to describe a very Python-esque way of doing something. And in fact, you can see, if you look at programmers who come from other languages, you can often see them speaking Python with the accent of a different language that they were maybe using before. In that sense, just like all of our natural languages, there are these idiomatic expressions, right? These kind of classic modes of expression, or a classic way to do things. And we're going to see that as we go through this semester with Python. So as we're creating these scripts, I'm going to do things in a Pythonic way. Maybe sometimes we'll do a first draft that's not very Pythonic, and then we'll come back and then we can revise it. As I mentioned, there is really no such thing as free-floating data in a computer program. We have to build a container to put that stuff into. Those containers are classically called variables because a thing that varies is changeable, or it shifts, or we can modify it in some way. And all of these data containers are modifiable like that, so that's why we call them variables. For now, we're going to start with really two kinds of data containers. This little slideshow lecture is going to talk about the first one, or the buckets. Some languages call these scalar variables. A scalar is just kind of like a number, but if that doesn't make any sense to you, don't worry about it. The metaphor of a bucket is a useful one because those kinds of variables can either contain one thing or no things. They're either full or they're empty. There's no halfway on all of those sorts of things. That's why I use a bucket to represent those. The second kind of variable that we're going to see in the next lecture is represented by a filing cabinet. And so those are we call them lists or dictionaries. But a filing cabinet, the variable is the entire cabinet itself. But the filing cabinet has a series of drawers. And in fact, it can have as many drawers as it wants. And believe it or not, you can even have a filing cabinet that has no drawers whatsoever. But every drawer is kind of like a bucket. It either contains one thing or no things. Right? And when we put data into a variable, whether that's a bucket or the drawer of a filing cabinet, we're saying that we are assigning data or assigning a value to that variable. And the contents of the bucket, or the contents of any individual filing cabinet drawer, it's called the value of the variable. So if somebody asks you, hey, what is the value of such and such a bucket? That means they want to know what the contents are, what's inside there. Every bucket has names. Every filing cabinet has names. And these are the labels that we attach to those variables. So it's not enough just to put data inside a variable. We have to give the variable a name as well. And that's how we get its value back later. So every time we're modifying it, every time we're assigning to it, every time we're doing something with it, we're actually citing the variable by name. Those names can only be one word long, and they can really only contain alphanumeric characters. And what that means is no spaces. So it has to be one word long. There can be numbers in there, but the variable name cannot start with a number. However, you'll notice here that underscores are acceptable. So all of these following things down here at the bottom are valid variable names. So I can just have one called name, or ID underscore number, or my favorite city in the world. And you'll notice there are multiple words there, but I've replaced the spaces with the underscore character. Same with cat 2. That style, believe it or not, is called snake case because it looks a little bit like a snake. I don't know. It doesn't even have anything to do with Python. So snake case just replaces all of the space characters with an underscore. You can also capitalize the different words in a multiple word variable name. And we call that camel case because it looks a little bit like the humps of a camel. Yeah, I know you might have to use your imagination on these, but there's snake case or camel case. Either is fine. It doesn't really matter. Nobody particularly cares. However, I will say that the Python community on the whole favors snake case. So if you're looking at Python programs elsewhere on GitHub or somebody else, or maybe somebody else is writing in a class, you will notice that the Python community tends to favor variables that are in snake case. When we put data inside a variable, we call that an assignment. And the character that we use to do assignment is actually the equals sign. Now, unlike what you saw in math, the equal sign doesn't really mean here that the thing on the left and the thing on the right are the same. Rather, it is a transitive verb, transit, right? Transit means movement. It moves something. So the equal sign in most programming languages is transitive. It moves data from the right-hand side to the left-hand side. And in fact, early on in the class here, when I read the equal sign, right, I'll review this and I always say, hey, it means figure out what's on the right-hand side of the equal sign. It doesn't matter how complicated it might be. Python will figure it out. And whatever the result of that complexity is, once Python simplifies it, take that and put it into the variable on the left-hand side. This is one of the lines in programming that we read basically from right to left. Almost always the rest of the time we can read left to right. But this is one that we read the other way around. So for example, apples equals 4. What that says is to Python, take the number 4 and put it into a bucket or variable called apples. So metaphorically, here's what I'm doing, right? I have a bucket, it has a label or a name attached to it called apples, and I'm putting the number 4 into that bucket. Same here, I have a bucket called name, and I'm putting an alphanumeric sequence into it, Bill. I'm going to talk about this in just a second, but you'll notice that those quotation marks are not actually part of the value. We're going to talk about this in a minute. These are meta characters, they're delimiters. So what that says is I want the value, the alphanumeric sequence, BILL, to be put into the bucket called name. Here, I'm doing a little bit of math. Remember, figure out what's on the right-hand side. Doesn't matter how complicated that is. Once you figure it out, put it into the bucket on the left-hand side. So here, obviously 4 plus 5 is 9. So it's going to put the number 9 into a bucket called price. Here's another clever one. This one says, take the alphanumeric sequence Bill and glue onto the end of it the alphanumeric sequence Shakespeare, and take that result and put it into the bucket called name. And you'll notice that addition works both for numbers and for alphanumeric data. This is a really smart thing. Python knows the difference. It's called overloading, but you don't really have to know that. But we'll see this again in just a second. Computers understand a few types of raw or primitive data. And I mentioned that there wasn't really any concept of free-floating data, but there is only in the sense that we can put it into a bucket. The two most elementary kinds of data are numbers and these alphanumeric sequences, which we are going to call strings. I'll talk about those in just a second. The numbers are probably pretty obvious. I mean, you've seen these probably most of your life, right? So I'm putting the number 4.99 into a bucket called price, or I'm putting an integer 7 into a variable called ID number. The tax rate is 0.05, or the temperature outside is minus 12.7 degrees. All of those are numbers, and Python understands their numbers. So when I put that data into a bucket like price, I can actually ask Python what kind of data is in that bucket. And Python can tell me that thing is a number. It's pretty smart about that sort of stuff. A string, and this is a definition that I'm going to use all the time, and so you should just remember what this is. A string is an alphanumeric sequence that cannot be changed or simplified. Strings can contain any letters at all. It doesn't matter. Python doesn't particularly care. As you look down below here, you can see that there's some Greek text, and there's also some German text with some umlauts in it and things like that. Python doesn't get bothered by any of that, so don't worry about it. You're working in Japanese or you're working in Russian, it doesn't matter. We can put anything we want in there, and that's fine. But Python needs to know where the string begins and where the string ends. And in order to do that, we use quotation marks. Now, it doesn't matter if you're using singles or doubles. Python doesn't care. You just have to use the same one at the end that you used at the beginning. But the quotation marks themselves are really meta characters. They delimit the string. They tell Python where it begins and where it ends, but they are not part of the string itself. So if I want to say how long is the string that I'm putting into the variable name, it's 4 letters long, BILL. Even though I've used single quotation marks here to delimit the beginning and the end, that doesn't really matter. Python doesn't care. Python looks at that and says, oh, here's a quotation mark, so I'm beginning a string. The first letter of that string is B, followed by an I, followed by an L, followed by an L, and oh, there's another quotation mark, therefore the string ends. Right? What's interesting is the bottom one, a phone number. And you'll notice that phone numbers, despite the fact that we call them numbers, are actually really strings. Remember, a string is a sequence that cannot be modified or simplified. So, if we didn't put the quotation marks on here, Python would think that was math, right? It would say, oh, that's 780 minus 555 minus 1,234. But that is not what we intend here. A phone number is a sequence of characters that cannot be changed. So, by putting the phone number into quotation marks, we convert it from a number, or a mathematical equation to be solved. We convert it from math into an alphanumeric sequence, or a string. So that's pretty important. One of the interesting things we can do with variables is that we can assign new values on the fly. And in fact, we can use a variable on the right-hand side and on the left-hand side. You go back, you might be having flashbacks to algebra at this point where your algebra teacher would freak out about this. But we can create an assignment on the right-hand side that uses some variables, and when we get the result, we can just put the result back into a variable that we happened to use previously, and that's totally fine. So for example, here I've got price equals, and then on the right-hand side is price plus price times a tax rate. So I'm obviously calculating at the register maybe, right, what some sort of product is that I'm purchasing, right? Now, there's some symbols here that maybe are new to you. The star always means multiply, if we know until we get to regular expressions. But the star means multiply. And so we don't use the X for that because it would be too confusing, because X is a legitimate character. So we don't use X to do that. We use the slash to divide. You can go into your weird character set and get a divide symbol, but that's really too hard to do. So we just use slash for dividing, and then plus is add and minus is subtracting, in exactly the way that you might have seen it before. What's new, though, perhaps, is that there's an order of operations here. There's a sequence by which these things get done. multiplication and division have a higher priority or a higher precedence than addition and subtraction. So multiplication and division are always done first before we go to addition and subtraction. If there's a whole bunch of these all in the line, we go left to right, but that's okay. What's important here is that price times tax rate will get performed by Python first before that number gets added to whatever the bucket price contains. And when we do that, what we're doing is creating a new number, and we will assign that to a variable. It just so happens that we're using a variable that we used on the left-hand side, on the right-hand side. So when price gets assigned to a new value, it overwrites or replaces the value of price on the right-hand side. So the old value of price is lost. A bucket contains either one thing or no things. And so when we put in a new value, the old value is lost. Can we get it back? No. If we needed to keep track of price over time, like let's say we wanted to keep track of our purchases over a month or something like that, whatever, a bucket probably is not the right container or the right data structure for us. And you might already be thinking, maybe a filing cabinet would be better for that. But that's for the next lecture. Let's just work through this really quickly so we can just see what this is. So let's imagine that the variable price has the number 5 in it. And so what we're doing here is really 5 plus 5 times 0.1. And we know already that the multiplication is going to get performed first. So that's the same as saying 5 plus 0.5. Is that right? Yeah, that is right. The math is so hard. So 5.5 plus 0.5, and what we do when we add those together then is we get 5.5, and that goes into the new bucket of price. So the old value of price has been overwritten with the new value of price. Totally fine. Variables vary. We can do a similar thing with strings. We already saw that we can glue one string to the back end of the other string. This is a process called concatenation. So as we go through the term, I'm going to use that as well. And when we're adding numbers, the plus sign means addition. When we're working with strings, the plus sign means concatenation. So in this case, if I'm taking the value in the bucket called first, I will concatenate onto the end of that a string consisting of one space, one blank space. And we know in Python we have to delimit the beginning and the end of a string with a quotation mark. So this might look a little bit weird, but this is a thing you'll get used to. This is a quotation mark, space, quotation mark. Right? One of my computer science professors always he drew a B with a slash through the stem of the B, called it a blank. And so I think he was a Vulcan actually. And so I have these memories of him like a blank. Anyway, okay, I'm digressing. So I'm concatenating the value of the bucket called first, and I'm concatenating onto that one blank space. And then I'm concatenating onto that the value of the bucket called last. And whatever that name is going to be, I'm going to put that into a new bucket called full name. Again, full name may perhaps have had a different value in it from earlier in my script. If so, I just overwrote it. So I've lost the previous value if there was one, and now I have a new value. But again, notice the plus sign works both for numbers and for strings. This is a concept called overloading, but as long as we're using strings consistently here, or as long as we're using numbers consistently here, Python will be able to figure that out. If we try and mix and match, You can actually try it. Maybe we'll do this in a second. If you mix a string and a number, Python will give you an error. It says, look, I don't know how to do that because the plus sign is both addition and concatenation. So which one do you want me to do? In this case, I don't know. So Python will complain for us a little bit. All right. One last thing, and then let's get into the terminal window and play with this just a little bit. The print command. The print command doesn't actually send anything to a printer. It just is a way to push output to the screen, whatever that happens to be. That might be the terminal window, right, or the Python PowerShell. It might be, you might be doing it in a web page, for example, or something else. So there are different avenues by which output can be delivered. But print takes data and pushes it towards the output, wherever that might be. So we have a brackets here or parentheses. We can put anything we want inside there. And again, just like in an assignment, Python will do its best to figure out what that thing is and try to display it the best as it can. So for example, I could just print the number 4 and I'll get 4 on the output, or I can print a string, hello, I'll get that string. You'll notice that it doesn't here have the quotation marks on it, right? So it leaves the quotes off. I can do this with variables as well. So I can say the name equals Bill. I can say print the name. There's my answer. And I can even do concatenation or even some really pretty sophisticated mathematics inside those parentheses. All right, that's the end of the slideshow. But what I'd like to do now is I'll just drop into a terminal window and we'll just experiment with this a little bit. All right, well, I've just opened a terminal window here. And if you are working on the Macintosh, again, this is in Applications, Utilities. It's an app called Terminal. And if you're working on Anaconda and Windows, you can either go into the PowerShell or you can just get into Python and you'll end up where I'm going to be here in just a second. So what I'd like to do on the command line here is just type Python, and that's going to get me into the interpretive shell. And you can see here that I'm running Python 3.7.1. Your version might be different, but it should be 3 point something, something, something. If you get in and you're running Python 2 point something, back out of this, you can get out of it just by typing exit, and you're back out. So you may need to go to Python 3. That might be the way that you get into it. But if you have any questions about this, let me know. You can email me and we'll figure that out. We can get on the Slack channel. You can post it on eClass or something like that. But if I get into Python, this is just the interpretive shell, and you'll notice that my prompt here are these 3 arrows. When I see the 3 arrows, I can just start typing Python, and Python will execute whatever those commands are, and then give me an answer again right away. So, for example, I can say, name equals Bill, and it has accepted that. I did not get an error message, so that means that everything is fine. I can say print name, and I will see that the response or the answer is Bill. What I can do here in the interpretive window, in the interpretive shell, is I can just ask Python, hey, what's in name? What is that thing? Then you'll notice that I get a string value, right? And now it has quotation marks on it. That string is Bill. So I can do all kinds of things. I can say price equals, it's hard to type, price equals 5. By the way, I can do this without spaces too, so whatever you prefer is totally fine. I tend to put spaces in there because over the years of teaching programming, I have found that the lack of spaces just interferes with people reading it. So I do tend to put spaces in. If you prefer not to put spaces in, that's totally fine. Python isn't going to care one way or the other. But I do add a little of the so-called white space just to make things a little bit more readable. So if I want to do something, I want to say price plus price times tax rate You can see there's 5.5. If I wanted to put that back into my variable, price equals price plus price times tax rate, and now I ask it what price is, you'll notice that it's now 5.5, right, which is fine. I can concatenate. Oops. If you start with the singles, end with the singles. Let me do doubles just for funsies. There you go. What's full name? There you go, Bill Shakespeare. One of the clever things about the interpretive shell here is that it has what's called tab completion. So if I just type F and I hit tab, well, that's not enough. A couple of letters, F-U-L-L, and then I hit tab. What Python does is it looks in its list of variables to see if there are any variables matching the letters that I have typed so far. And if there is, it will auto-complete that name, which is actually pretty great. So that helps you speed things up a little bit when you're typing. This works a lot too, by the way, in text editors. But if I want to ask for a variable that doesn't exist, you'll notice that Python gives me an error message, right? Look at the bottom line here. That's what's important. Name error. The name apples is not defined. So what that says is that Python looked in its list of all of the variables that I have used and defined thus far, and apples is not on that list. Apples is not a name that I have defined. It's not a variable that I have defined. And so you'll see that I get this thing here, a name error, right? And again, we talked about this a little bit in a session earlier, which is that many people get really worried about this. They feel that this is them making a mistake, that they should feel guilty or they should feel bad or they should feel stupid because they got an error message. But this is just really Python's way of having a conversation with us. It maybe gives us more information than we're really interested in at this point, but that's okay. This is just the way that Python has a conversation with us, and so we just need to start to learn how it has a conversation with us. We need to interpret its intentions properly. And in this case, a name error just refers to a variable that I haven't defined yet. And again, if I want to get out, I can just type exit and I'm back. And that's all there is to that. All right, that's the end of this little exercise on variables and data containers. We'll move on to the next one, which is slightly more sophisticated data containers, the metaphorical filing cabinets. Thanks.